Hello, today in class we're going to be talking about variance and standard deviation of the discrete random variable. I hope you enjoyed today's lesson. We've already talked about what is the expected value. We said the expected value of a discrete random variable can be considered the long-term average or the mean. Well, we can now consider variance and standard deviation. Once we know what our mean is, which is considered the expected value, we can look at variance, and variance and standard deviation both provide a measure of spread. How far is the data spread about the mean, or the expected value, which we're considering the long-term mean. The average of the squared deviations about the mean is what variance is. That's nothing new. We've seen that before with our regular variance, but now we're talking about variance of the discrete random variable. Well, you need to know these two formulas. Variance of x is defined as the expected value of x squared minus the expected value squared. Again, that's the expected value of x squared. Notice that's in parentheses minus the whole thing in parentheses now, the expected value squared. Well, how do we go from variance to standard deviation? Of course, we take the square root, which is the expected value of x squared minus, in parentheses, ex squared. We're going to take the square root of all of that. You have to memorize this and this if you want to get these problems right. Let's do some examples and see how they work. When we are dealing with discrete random variables, we use variance of x. This is a capital X. It's the DRV, the discrete random variable. And we've seen, you need to know this, it's the expected value of x squared minus the expected value of x, the whole thing squared. Sometimes you see this written as a capital U like that, so it's e of x squared minus this u. We call this sigma squared. That's another word for variance. You have to realize that that's sigma squared. Well, how do we go from variance to standard deviation? Take the square root. So standard deviation of the discrete random variable, capital X, is the square root of variance, which is designated sigma. To measure spread of the discrete random variable, we use standard deviation because it's a better measure of spread because the standard deviation is in the same units as the mean or the expected value. The expected value has the same units as standard deviation. The variance has squares of that value, of that unit rather. So we use this, again, standard deviation goes with the expected value to measure spread, and it's the square root of variance. Why? Because it's in the same units as our expected value. Let's do a problem where we have to deal with measure of spread and the discrete random variable. Here's a probability distribution of a random variable x. Here it is. It gives you what is x equal. The discrete values that our capital X can take on are -2, -1, 0, 1, and 2. What are the probabilities associated with each of these discrete outcomes? 1 over 64, 12 over 64, 38 over 64, 12 over 64, 1 over 64. Our problem here says find the variance of x. Well, you need to know the variance of x is the expected value of x squared minus the expected value squared. Well, let's find expected value of x squared, and let's also find the expected value of x and then square it. And we'll take the first one minus the second one. That will be the philosophy behind our doing this problem. So our first step in this problem is to find what is the expected value of x squared. If we're going to find the variance, this is our first step. Well, that requires us to take the x, which our capital X could be defined as, which is these values here, which are these values here, and square them and then multiply by their corresponding probabilities. -2 squared times its probability, 1 over 64. We're going to sum them, plus -1 squared times 12 over 64, plus we're going to sum them. 0 squared times 38 over 64, plus 1 square it times its probability, 12 over 64, plus 2 squared times 1 over 64, which is its corresponding probability. Well, when I multiply this, add this, multiply this, add this, etc. When I do this problem out, that's easy. Freshman, sophomore math, I finally get 1/2 there. That is my e, x squared is 1/2. Continuing on with our variance problem here, we know that variance is e of x squared minus e to the x squared. We already found out e to the x squared in our last work was 1/2. And we're going to subtract out e to the x squared. Well, how do we find e of x, the expected value? The expected value is simply the values that our x, our discrete random variable, can take on times their corresponding probability. It's called the expected value. It can be thought of as the long-term mean. Well, how do we get that? It's -2 times 1/64, plus -1 times this probability, plus 0 times this probability, plus 1 times this probability, plus 2 times 1/64, which is its probability. And you can trust me, when you do this easy math, it comes out to 0. Well, that's the expected value. And we're asked to find the expected value squared. So all we have to do is find the expected value and then square it, which still gives us 0. So if we're following the formula for variance, it would be 1/2, which we found earlier, minus 0 squared, which is 0, which gives us 1/2. So we know that that's our variance. Well, what is the standard deviation of this discrete random variable x? The standard deviation is going to be the square root of our variance, and that will be, of course, the square root of 1/2.